What if I told you that every star in the sky has a story? A story that spans billions of years, from a swirling cloud of gas and dust to a spectacular explosion that can outshine an entire galaxy. Welcome to Nature's Insight channel, where today we explore the incredible life cycle of stars. Join us as we journey from the birth of stars in cosmic nurseries to their dramatic deaths as supernovae, black holes, or neutron stars. Prepare to be amazed by the cosmic dance that shapes our universe. Our journey begins in vast, dark regions of space known as nebulae. These are the stellar nurseries where stars are born. Nebulae are composed of gas, primarily hydrogen, and dust. Within these clouds, pockets of gas and dust begin to collapse under their own gravity. As they collapse, they heat up, and a protostar is formed at the center. This process can take millions of years, but eventually the core temperature of the protostar becomes high enough to ignite nuclear fusion. Nuclear fusion is the process that powers stars. In the core of the young star, hydrogen atoms are fused together to form helium, releasing immense amounts of energy in the process. This energy radiates outwards, creating a balance between the inward pull of gravity and the outward pressure of radiation. This balance allows the star to enter the longest phase of its life, the main sequence. During the main sequence phase, which can last billions of years, a star shines steadily, converting hydrogen into helium in its core. The length of time a star spends in the main sequence depends on its mass. Massive stars burn through their fuel much faster than smaller stars, leading to shorter lifespans. Our own Sun, a relatively average-sized star, will spend about 10 billion years in the main sequence phase. As a star exhausts its hydrogen fuel, it enters the next stage of its life cycle. For a star like our Sun, the core contracts and heats up, causing the outer layers to expand. The star becomes a red giant, growing in size and cooling at its surface. In this phase, the star begins to fuse helium into heavier elements like carbon and oxygen. Eventually, the outer layers are ejected into space, forming a beautiful planetary nebula, while the core remains as a white dwarf. This white dwarf will gradually cool and fade over billions of years. But what happens to more massive stars? Their life cycle ends in a far more dramatic fashion. When a massive star exhausts its nuclear fuel, the core collapses under gravity, reaching temperatures so high that it triggers the fusion of heavier elements like iron. However, iron fusion does not produce energy, and the core can no longer support itself. The result is a catastrophic collapse, followed by a colossal explosion known as a supernova. A supernova is one of the most energetic events in the universe. It can outshine entire galaxies for a brief period and release more energy in a few seconds than our Sun will in its entire lifetime. The explosion blasts the outer layers of the star into space, enriching the interstellar medium with heavy elements. These elements are the building blocks of planets and life, including the very atoms in our bodies. The core of the star, left behind after the supernova, can take one of two extraordinary paths. If the core is between 1.4 and 3 times the mass of our Sun, it will become a neutron star. Neutron stars are incredibly dense, with a single teaspoon of their material weighing as much as a mountain. They are composed almost entirely of neutrons and have intense magnetic fields. Some neutron stars become pulsars, emitting beams of radiation that sweep across space like cosmic lighthouses. However, if the core is more than 3 times the mass of our Sun, it will collapse into a black hole. Black holes are regions of space where gravity is so strong that not even light can escape. The boundary surrounding a black hole is called the event horizon, beyond which nothing can return. Black holes are mysterious and fascinating objects, warping space-time and influencing the surrounding matter and energy in profound ways. As we conclude our exploration of the life cycle of stars, it's clear that these celestial objects play a crucial role in shaping the universe. From their birth in nebulae to their spectacular deaths as supernovae, black holes, or neutron stars, stars are the engines of cosmic evolution. They create the elements that form planets and life, and their light illuminates the universe. Thank you for joining us on this captivating journey through the birth and death of stars. We hope you've gained a deeper appreciation for the incredible processes that govern the cosmos. Don't forget to like, share, and subscribe to Nature's Insight channel for more amazing stories from the natural world. Until next time, stay curious and keep exploring.